Good morning, children. Today I am making this video because you have your upcoming exam on Monday. You have your chemistry exam, so I'll give you a quick recap of the entire syllabus. I will give you the detail, like how to prepare for each and every chapter, where to concentrate, and how to present your answer in a quick recap of all the chapters. We'll go page wise, and I am referring the Viraf Dalal book. We'll start with the chapter number 1. In chapter number 1, you can see that that is your periodic table and periodic properties. You can start with page number 7. In page number 7, you can see that there are alkali metal and halogens comparison is given. So here many properties are given. Please pay attention on this specific property, that why alkali metals are good reducing agent, and your group 17 element halogens are considered as best oxidizing agent. Okay, while giving this answer, you need to mention that why alkali metals are good reducing agent, because they have only one electron in their valence shell, and which they can lose or donate easily. Okay, similarly, when you are talking about the oxidizing property of group 17 element, then you need to say that because they have lack of only one electron, they need only one electron in their valence shell, which they can accept easily. That is why they are the example of best oxidizing agent in the periodic table. Okay, so here many properties are given in page number 7, but mainly you pay attention on the reducing and oxidizing. Right now, when we are going through all the 5 periodic properties which we have, that is atomic radius, ionization potential, electron affinity, electronegativity, metallic and non-metallic character, just look at page number 8 quickly. So here you should know that what is the reason for periodicity. Okay, and what are these 5 periodic properties. In these 5 periodic properties, you should know exact definition. The definition will be there in the question paper. You need to identify the term. What is the specific term? For example, suppose I am saying that the amount of energy, name the following. The amount of energy which is required to remove an electron from the valence shell of an isolated gaseous atom, then the answer is ionization potential. So you need to recognize. So when I am saying energy required, that is ionization potential. When we are talking about energy released, that is electron affinity. Okay, so this part you need to prepare accordingly. What about metallic and non-metallic character? Metallic, non-metallic character. Metallic character means the electropositive character, how easily someone can lose electron and how easily someone can gain electron. That defines the non-metallic character. Okay, so now in page number 9, you can see that they discuss about the first periodic property, that is atomic size. In atomic size, you need to know that how it like periodic trend, how it increases or decreases, how it is changes when you are moving across the period and down the group. Okay, so you should know how it increases or decreases across the period, and also you should know what are the factors, why it is increasing, why it is decreasing. Right, so when you are moving across the period, you will say it decreases because the number of shells are not changing, but the number of electrons are increasing by 1 unit. Okay, and when you are moving from top to bottom, or you can say when you are moving down the group, what will you notice? That the number of shells are increasing, as well as the number of the nuclear charge is also increasing, but the increase in one shell dominates over the increase in the number of your nuclear charge. Okay, so that is why the size will increase. So this is one point. Now if you see one more point, if you can see in Viraf Dalal, the page number 9, the third point. Okay, there is a small line which is given, that is also you should know that a cation is always smaller than its parent atom. That means if I am asking you sodium is bigger in size or sodium ion, you will say sodium atom is bigger in size, because when sodium changes into sodium ion, it is losing one electron, so the remaining electron experience the greater nuclear charge. Okay, and there is a decrease in one shell also, because sodium is having 2, 8, 1 shell, 3 shells are there, whereas sodium ion is having only 2 shells. Okay, so this is one point. One more point regarding the ionization potential, again how it increases down the group, or how it changes down the group, or how it changes across the period, that you should know. In this you should remember that which element in the entire periodic table is having least ionization potential. Very important point, you just pay attention on that. That is cesium. You will not take francium. Okay, first of all, alkali metals have low ionization potential because of their biggest size in every period, right? But because each period starts with alkali metal, but among alkali metals, cesium will have the least ionization potential. And if I am asking you in the periodic table which group elements will have highest ionization potential, that is noble gases. Okay, now among noble gases, if I'm asking you, that will you will say helium, because ionization potential depends upon the size, right? The smaller the size, greater the ionization potential. So that will be highest for helium, least for cesium. With these two terms you should remember. Now regarding the affinity, very important, regarding the affinity, definition can be asked to you, or definition will be there in the paper. You need to identify the term. This is one thing. Second thing, which group elements have zero affinity, no affection for electron at all, that you know, that is noble gases. And why noble gases have zero affinity, that is another reasoning question, right? So while giving the answer for any reasoning question, you need to remember that you need to pay attention on the keywords. Please include the keywords in your all the reasoning and give reason based questions. Okay, include the keyword. Without keyword, even if you are explaining for a half paragraph or a detailed explanation is there, you will not get any kind of mark. So please include the keyword in your every reasoning explanation. So regarding the electron affinity, if we ask you why noble gases have zero affinity, you will say because they have a stable electronic configuration in their valence shell. In case of helium, duplet is completed. In case of other noble gases, octet is completed. That is why they do not have any affection for electron, and hence their electron affinity is equal to 0. Okay, next is one more point, that if we are asking you which group elements have highest affinity, then it will be halogens. Okay, among halogens you should remember that see what is the expected order. We'll say that when we move down the group, the size is increasing, so hence affinity should decrease. But the order of affinity is not like this. You can't say the affinity of fluorine, chlorine, bromine, iodine. It is not the correct order. Please pay attention. This can be given to you in your board exam in the form of options, MCQ, right? Or it can be asked to you that write the following halogens in their increasing or decreasing order of affinity. So affinity of chlorine is highest. That is an anomalous behavior of halogen. Please remember, chlorine, fluorine, then bromine and iodine. Okay, so there is an interchange between the position of fluorine and chlorine. So chlorine will come first, not fluorine, right? So this is very important point regarding their affinity. Now if we come to electronegativity definition, you should know what is the definition and how it increases, decreases down the group across the period. Same thing for metallic character, how it is changing across the period down the group. So all these properties you should know in terms of the variation across the period and down the group. Okay, so these are few things which you need to pay attention from your chapter number 1. Okay, I will discuss about chapter number 2 in my next video. Thank you for watching my video.